Hi, in this video we will learn about a popular technique called clustering and how to do it in R. So clustering, as we all know, is an unsupervised classification technique where the purpose is to group similar points which are close to each other into one cluster. Therefore, clustering involves the finding out of similarities and differences within a data set, and the purpose is to group the similar items together and form clusters. So intra-cluster similarity will be very high because items placed under a single cluster will have a high level of similarity among each other. However, if there are two clusters, they should be as different and as distinct from each other as possible. So that defines how good a clustering is. This we will learn using the k-means clustering technique in R, and for this we'll use a data set called iris. So I load the data set, data of iris, which is an inbuilt data set in R, and we have a look of how the data set is and what it comprises. So this shows the sepal length, sepal width, the petal length and the petal width of a few species of flowers, and the dependent variable here is the species to which the unit belongs to. So there are three kinds of species of flowers which are being considered here. So the number of species in this entire data set is 3, and the number of rows here is 150. So there are 150 entries of different kinds of flowers, and based on the characteristics of their sepal length width and the petals length width, they are been classified into 3 kinds of species. So they could be either of these 3 species. So the purpose here is to classify each of these units into which of the species they fall into. So for that we'll create another data set where the species is absent. So say I1 is another data set where I1 is equal to iris. So we have a copy of the data set and we'll work with this copy so that the original data set remains undisturbed. And iris I1 species will be equal to null. So the last column of this new data set I1 has the null defined. So if we see head of I1, it will have the first 4 columns, but the 5th column is missing, which is supposed to be found out. So R has an inbuilt function known as the k-means, which uses the function of the k-means clustering algorithm and then gives the results of which is the cluster into which each of these observations can be put into. So I say result res is equal to k-means of I1, comma, the number of clusters. So because here I know that the number of species contained in this entire data set is 3, I will want to create 3 clusters. So basically all these 150 elements have to be classified and put into either of these 3 species. So I write res is equal to k-means I1, comma 3, and then I see the results. So the result shows me that the k-means clustering has formed 3 clusters and the sizes are 50, 38 and 62, and they all add up to 150 elements. The cluster means have been shown by the small table. So the first cluster has a mean of sepal length as 5.006, a sepal width of 3.42, a petal length of 1.46 and a petal width of 0.24, and all the numbers can be interpreted accordingly. Now the clustering vector shows how each of these 150 units are put into either of these 3 clusters. So if you see the first, second, third and so on up till so many units, so many observations have been put into cluster number 1. The 82nd observation belongs to the cluster number 3. These observations belong to cluster number 2 and so on. And there is also a measure known as the within cluster sum of squares by the cluster, which is formed by the amount of the sum of squares within each cluster divided by the total sum of squares. And this also, the result also shows us the value of the clusters, the centers and a few other attributes for this result. Now suppose I want to see the size of each of the clusters formed. So I write res $size will give me the size of the 3 clusters formed. So the sizes are 50, 38 and 62. Now if I want to see the clusters which are formed, I can write res $clusters cluster, and I see that the result is as below. So it shows that these 150 observations have each of them classified into result number, the cluster number 1, 2 or 3. Now I want to see how good this fit has been. So how do I do that? I plot the result, say iris of C. I want to do it against petal length and petal width, so I write petal dot length, which is the name of the column, comma, petal dot width, and I color them according to the results of the cluster. So res dollar cluster. So depending on which cluster they fall into, they will have different colors for each of them. And we see that the result has a small error, so it has to be okay. So this should not be there, and we see that the result is like this. So we see when we plot the petal length and the petal width against each other, the black, the green and the red circles show us the 3 clusters which are formed as a result of these k-means clustering. So the sizes are 50, 38 and 62 respectively. Now we want to see how good it has been in terms of the original cluster. So this is the result which we have found out of the k-means clustering. I plot the same thing by keeping the color as the one which was present in the original data set, for which I write iris dollar species, and see that the result is this. So if you see, it is not much different from what we obtained as a result of the k-means clustering, which shows that our result has been pretty good in explaining the clustering process. For this we can have another process by plotting the table of our results versus the original results. So I can write iris dollar species, which is as it is in the original data set, against the results dollar cluster, which will plot how I have obtained it as a result of the k-means exercise. Now this table shows that the species Sentosa had 50 observations, which has been clearly defined according to our k-means example also, because all the 50 units, all the 50 observations are found under the same cluster. For the second cluster, for the second species versicolor, which belongs to cluster 3, out of the 50, 2 of them have been come into the second cluster and the rest 48 are there in the third cluster. So there's a small error or a small discrepancy in terms of 2 observations. Similarly, here in case of the next species Virginica, we see out of 40, out of the total of 50 which belong to the cluster 2, 36 have been correctly specified to belong to cluster 2, but 14 have been specified to belong to cluster 3. So we see that the performance has been pretty good and the error is not too high, and therefore the k-means algorithm has been successfully able to predict or to classify each of these 150 observations into one of these 3 species into which they fall into. Now suppose instead of the petal length and the petal width, I want to see according to the sepal length and the sepal width. So for that I plot iris C sepal dot length, comma, sepal dot width, comma, color is equal to result dollar cluster. So that is how we have obtained it to be, and we see that the clustering result is as below. So the black, the green and the red circles show how 3 of these clusters are formed. To see how they have performed against the original specification in the data set, we do it again by keeping the colors as the original data set. So color is equal to iris dollar species, which shows me this figure, which is more or less the same as what we had obtained from the previous statement. So we see that our k-means clustering algorithm has been able to classify each of these observations into one of these 3 species quite successfully. The results have been pretty good, And that is how k-means clustering can be used to classify similar objects, similar units into clusters and keeping distinct objects absolutely different. Thank you.